Even with careful setup and regular testing, CNC machines can develop accuracy issues over time. Common problems include backlash in the axes, spindle misalignment, worn ball screws, and thermal expansion when the machine has not fully stabilized. These issues slowly reduce precision and can cause parts to drift out of tolerance. Backlash and worn components affect how accurately the machine reaches commanded positions, while spindle misalignment directly impacts surface finish and dimensional accuracy. Thermal expansion is another major factor, especially during long production runs, where temperature changes cause parts to deviate without any visible machine fault. To fix these issues, it is important to adjust machine parameters, replace worn components when necessary, and perform recalibration to restore correct geometry. Preventive actions such as regular lubrication, cleaning, and monitoring environmental conditions help minimize accuracy problems before they affect production. Maintaining CNC accuracy requires consistent preventive maintenance. Keeping the machine clean, properly lubricated, and periodically calibrated prevents small errors from accumulating into serious problems. Monitoring temperature, humidity, and vibration also plays a key role in sustaining reliable performance. Looking ahead, improving CNC accuracy means combining basic maintenance practices with modern technology. Regular calibration, tool wear monitoring, and environmental control remain essential, but newer solutions such as real-time monitoring systems, smart sensors, and improved feedback devices help detect accuracy loss early. Investing in operator training ensures that accuracy data is understood and acted on correctly. By addressing accuracy issues early and maintaining a routine maintenance plan, you protect part quality, reduce scrap, and ensure your CNC machine continues to produce parts within required tolerances. If this explanation helped you, like the video and subscribe for more practical CNC troubleshooting.